Hello, hello. No one's here yet, but still. How's everyone doing? Going live? Cool. Here's a little messy, but whatever. So, today I'm going to be working on, basically keep working on the LRUCache that we've been working on. So last week, actually let me pull this up. Last week what did we do? We basically finished up making the LRUCache. So if I go to see LRUCache, actually maybe it's bigger so you can see a little better. Yeah, it's good. I think you'll be able to see from there. Alright, so let's actually, what did we build? We had the element, so new, get, and set. So we built the LRUCache and we have the get and set methods, and just to make sure that everything still works. Make test. Make sure all the tests work. Let's see what oh, let's go to LRUCache. Alright, make test here. So all the tests are passing, and the only methods we have for this cache are get and set. I realize actually that we might want to have invalidate. The reason for that is whenever so caches are great for fetching something really quickly, but when let's say that you have something in the cache, but you send a update request. So like say you have a cache, you have a data store, and the cache has cache things in the data store, or cache things that are in the data store. If you send an update request to the data store to update the resource that has been cached, if you try and then refetch something from the cache again, it's gonna be stale. So what we want to do is whenever we send an update request to our data store, we also want to invalidate that key that's in our cache. So I've created the set and get functions for our cache, but we also want to have an invalidate method. So that's what we're doing today. So I'll add the invalidate, add some tests for it, and then we're gonna actually start building this out and testing it out, because I actually want to test out the cache and see how it works. So we're gonna actually, after that happens, after we make the invalidate request, we're going to actually create an API with this, because I'm gonna make an API with a couple endpoints. API is gonna be connected to a SQL data store, and we'll actually test out like how this cache works. So we'll send update requests to the data store. Whenever we get something from the data store, we're gonna store it in a cache, and then we can actually test out how fast the cache is, because every time we pull something from the cache, it should be much faster than pulling from our SQL database. So that's the plan for today, and yeah, we'll see how far we get with it. And then we are doing coding a cocktail, so if anyone's interested, I have a Jack and Coke, or no, I Coke and rum right now. I have like a drinking from. We went to Vermont recently and did some kind of like, or somewhat recently, we got some drinks or some rum and whiskey while we were in Vermont at the Mad Hat Distillery. It's pretty good rum, so pretty happy with it. Okay, first task. First task is going to be creating that invalidate endpoint. Let's see if I can set up a little bit. Okay, cool. So first thing is going to be, we're going to go to our LRUCache. Of course, Vim is not always nice. There we go. So we are in our invalidate cache. So I've created set and get, like I mentioned, but we want to do invalidate. And so invalidate, what it's basically doing is we're telling the cache that we want to basically remove the value of a certain key. So we're gonna do func, and we're gonna do LRUCache, and we're gonna do, oops, I just misspelled that, and do invalidate. And so we're gonna accept a key as a string, and we have an error back, so that if something goes wrong, we'll return an error. I'm not sure we'll necessarily get an error, but in case there's an error, we'll return an error. All right, so what we need to do is basically what we're gonna do for the invalidate is since we're manipulating our cache, the underlying data structure, we probably want to lock our mutex. So that way, anyone who is not familiar, a mutex is basically a way for, if you have multiple threads trying to access the same data store, you use a mutex to try basically make it so only one thread can access the data store at a time. Because if you have multiple threads all trying to talk to the data store at once, you get like race conditions and incorrupt data and all that stuff. So what we're going to do is we're going to first lock our mutex. To lock, cool. And then we're going to defer unlocking it. So once this function finishes, we're going to unlock it so that other threads can then access the mutex. All right, so the next thing we're going to do is we're basically going to call our list. So the list is the data structure, and we're going to do remove. Oh, it has to be a node. Okay, so first thing we're going to do is we're going to get. Yes, I think do I have that method actually for my list? If I don't, I'll have to implement that. All right, well, what we're gonna do is we're going to have to basically remove a node, right? Oh, you know what I'm gonna do? Okay, I know what I'm gonna do. So since I have this map already that has all my node items, I can just pull from here. I'm gonna pull from my items list, kind of similar down here. I'm gonna pull from my items list, see if the node exists. If it doesn't exist, then I don't do anything. The key doesn't exist, I don't need to invalidate it. If it does exist, then I'm going to pass in the node to the remove endpoint from my linked list, and that way I'll remove the node. So that'll work. So I got node exists. If it doesn't exist, so it doesn't exist, we're just gonna return nil. So there's no error. You know, if the key doesn't exist, it's not really an error. We're just gonna return nothing. If the node does exist, then we're going to let's see. We're going to go to the lists, and we're going to remove and pass in the node. And then what was this have any? So it doesn't return any errors. So not gonna return an error. We're just gonna assume it's gonna work. And then so that will remove the node from our linked list. Now what we're gonna do is we're going to actually remove it from our items list, our map, essentially. So we're going to remove the key. So once we've removed it from our linked list, which is basically our data store. Hey, how's it going? Hey James, how's it going? Thanks for joining today. Cheers, man. Oh yeah, I heard actually that Launch School is doing a C seminar. I haven't done it. I actually haven't joined, or I haven't looked at it. But it sounds really interesting. I think definitely. I actually don't know anything about. I know a little C. I did a little C++ when I was like going through like my CS degree. I did a little bit C++, but I barely remember anything. But yeah, definitely C is really good to learn. Like, it'll definitely give you some low level like understanding of how this works. Like right now, I'm using Go. Go is I would say nicer than C, just because it's easier to read in my opinion, and it kind of gives you nicer things out of the box. Whereas C, you know, is like you can definitely it gives you the rope to hang yourself essentially. You know, when it comes to like, for example, accessing arrays, I think in C you can technically access things outside the array and it won't return error. It'll just let you do that. Whereas in Go, it'll actually panic if you try and access something that's out of an array size. But yeah, so I think definitely if you, if you're attending the C workshop or a C seminar for Launch School, definitely a very good thing to know. Or it'll be very useful to know. Oh, nice. Yeah, threads and processes are very interesting. Like, I mean, you can see here, you know, I'm using this mutex right here, mutex lock and mutex unlock. If you're, so mutexes, you probably are learning about mutexes. So yeah, mutexes are very important when it comes to multiple threads. And also, like, one thing that I mentioned too is I'm not sure if C has this, but so for the Go, I can do a read-write mutex, meaning that if I want to fetch something from, if I have multiple threads who are trying to fetch something, we can use like a read-only lock. So for example, right here, I have a mutex doing a read lock, and that won't prevent another thread from doing a write operation, but it'll lock all things trying to reads. So you actually see the definition here. It's for read locking, whereas like you have also, if you're trying to write or update something, you do a write lock, which is what I do up here. So in the validate, since we are updating our map and we're updating our linked list, I'm using a write lock. Whereas if I'm just fetching something, I'm doing a read lock. I'm not sure if Go has those. Steve has those. I'm sure they do. It's not really a language specific feature. It's just kind of like an overall idea. Yeah. So how is that going? Like, are you basically like, when you say you're volunteering, are you the one presenting? Like, do you present the thing, like that chapter, for like other people in the seminar? Is that how it works? So we got move to lead. That should work. Let's start some test for this actually too. Edit. I'm gonna do. All right, so we're gonna write some. Oh, cool. Yeah, so you're gonna present it. Nice. All right. That's cool. Yeah, I mean, definitely. Threads and the presenters aren't chosen yet. Okay. But when you said, you and, sorry, I think it's Bharat, is that how you pronounce his name? Volunteered for the Threads chapter. When you say volunteer, do you mean like you're gonna research it, or like but you're not presenting it? Or what do you mean by volunteered? Oh, gotcha. Okay, so you will present it, or you're volunteering to. Oh, so when you said volunteered, but you volunteered for it, but you actually haven't been necessarily picked to do it. Is that what you mean? Date. Oh, let's go. Gotcha. Okay, that makes sense. Cool. Are you excited? Like, what made you pick threads? Is that like something about threads that interests you? So this test case is going to be validating basically like yeah, definitely, like threads and processes are definitely really interesting. I remember when I was doing like what was it? Oh, when I was interviewing for jobs, I would actually yeah, no problem. I'm glad you enjoy it. But actually, one thing I would definitely suggest, so when I was doing job interviews, I definitely read a lot about threads and processes. And actually, during one of my tech interviews, they asked me, like, what's the difference between multi-threading, multi-processes, and like the difference between thread memory and process memory and all that stuff. So they, during my interviews, they actually did ask me that. And I would highly suggest, there was a capstone project that did a lot of work on threads and processes. It was called Workaholic. They basically made like a job processor in Ruby. I would definitely suggest looking up their their white paper on it. I can actually look it up too. Let's look it up. Let's see if I can find it. Yeah, if you haven't looked up Workaholic, let's see. Let's do. GitHub. Here we go. Yeah, so their white paper does a lot of stuff on. Yeah, this is it. Antoine, he was part of the team. They have here we go. Still work. Yeah, so they basically built a job processor in Ruby using like Redis. And so one cool thing actually, this section really helped me a lot when I was doing my job interview. Where was it? I think it's this section. So concurrency. They talk about like how they use concurrency, and so they, you know, these diagrams. I actually borrowed/stole these diagrams for like a presentation I did. And so yeah, this whole section does like a really good. They do a really good job of explaining kind of threads and processes. I mean, it's gonna be different with C just because you're gonna be lower level, but it might be useful to read this. I definitely got a lot out of this when I was doing my job interview, and it helped me get the job I have now. Was knowing and understanding the difference between threads and processes. But yeah, this workaholic.github.io/concurrency. I would definitely suggest. Actually, maybe I can post it in the chat. I was just looking at that. That was really good section to read for me. Yeah, it was really good. Yeah, that's super interesting that you're doing the processing threads. It definitely is a really interesting topic. Let's see if I can work on. Let's do some test cases for this invalidate. So for invalidating, we want to do empty key. So we're going to create a cache with just a size of 1. We're not going to do a setting because we're just going to say that's empty set. And then, or actually, I think invalidating empty key might even be useful. Let's see, because like nothing really happens if I invalidate empty key. Doesn't exist. Yeah, it doesn't remove. I think one thing I could do is maybe do some mocking, but I'll do that later. So let's just do invalidate in use key. Okay, so we're gonna do, oh shoot, a test file. Okay, so we're gonna do a test for this. So invalidate in use key. So we're gonna set this to bar, and then what we're gonna do is we're going to invalidate bar. Oh, actually, before we do that, what we're gonna do first is we're gonna actually get to the value. And so that we can assert that it does exist. So cache get, come on, bar. And so this will, what will this give us? What do I return? Get, I just get, I turn the value. Okay. So if I do, and then I convert it to a string, I can do assert equal async the, so foo is actually the value. Okay, so foo is a key actually. So foo. All right. So we're going to get, so bar, I'm asserting that bar is going to be the value that we get when we do this. So that should pass. And then what I'm going to do next is I'm going to invalidate, I'm going to do invalidate foo. What's wrong? I think it's because I'm trying to make this return something, but it's not. All right, so I'm going to invalidate foo, and then what I'm going to do afterwards is I'm going to assert that essentially this is going to return nil. So I'm going to do cache get foo, and so this should be nil now. Cache invalidate. Okay, so that should be foo. So let's run this test. Cool. So it works. So basically, yeah, when we do set it, it's gonna be, we're gonna get the value bar, and then when we invalidate it, what we're saying is that when we try and get it again, it's not working. So perfect. Our cache is indeed working. So that was good. So that's all I needed. So the reason I want to do that is because, like I mentioned before in the beginning, I want to actually now create an API endpoint that is attached to like a SQL database. So what we're going to do is for that. So let's go back here. So now we're at the kind of main part. So over here, we're kind of the main part. So we have our linked list done for the most part. Our LRUCache is done with some tests. You know, we got some basic tests. So now what I'm going to do is I actually want to create an API endpoint that will basically has like maybe a get and set endpoints, and then we're going to have a database attached to this. So let's go.
I'm just happy. I've never felt that before.
I don't know what song this is. That's not bad. All right, so I know Go has a Gorilla Mux library that's really often I've used it in the past for creating API endpoints. So that's what I'm gonna use here. That's what we're going to use for creating our API endpoints. So let's actually see the documentation. So I used it in the past before, but it's been a while since I've used it, so I need to up myself on the implementation or how to use it. All right, so we're going to need to install it. So basically, this is just importing the package. Cool, that will work. Okay, so all we need to do is, it's pretty simple. So we're just going to be creating the router. Then we basically pass in. So we define the endpoints, and then we pass in a function, like a function that will basically essentially handle that endpoint, and then we call HTTP handle. Okay, so that's pretty easy. So I'm gonna go to the main package. Let's see where we at main. So let's go. There we go. All right, so we got our main command here. So the main is basically the entry point to our program. So whenever we, like, if I want to run an API, I'm gonna define like the API here, because I want to, when I start the API, I'm gonna call the main, basically, essentially I'm gonna do go run main, and it'll start up the API. So if I look at this, we can kind of steal this. Let's just steal that and see how it works. Perfect. Does it import correctly? Cool. So it automatically imported Gorilla Mux because it knows about it. Cool. So we're gonna start the router. Let's say the main. Let's see. I think just for testing purposes, we're gonna do like a set a message and then retrieve a message. And we want to list all the messages. So let's say, how about that? I'm gonna do message, and then this would be like a messages handler, something like that. Oh, but we need to actually pass in. I think we can also specify the method that we want, because you know, we want to have also get requests and post requests. So we want to make sure that, okay, here it is. So there's methods here. We want to add the methods to it. So we want to make sure that messages endpoint is going to be a get request. Method get. All right, so and then the next endpoint we want to do is to create a message. So it's going to be the same thing as the messages. So list messages handler, and then also create message handler. Methods, method post. We're going to post, we're going to accept post request to that endpoint. And then if you want to get a specific message, we're going to do, let's see, get message handler. So make sure, okay. So they say in the documentation that we can specify here we go. So we can basically say, all right, what we're gonna do here is maybe message ID. So we're actually gonna do this. So what this means, we're just saying so basically what's happening behind the scenes is that this is like a regex, Gorilla Mux is using this string as like a regex string. So if I send a request to this endpoint and it matches, and it matches this, so it's gonna be messages, and it has like some sort of number afterwards. So this is like a regex right here. So like if it contains a number from 0 to 9 with at least one character, it's gonna match that. And so it's gonna pass the message to the get message handler, as opposed to if it's like dot messages for the post request, it's gonna go to this one. So I'm just defining my endpoints. Let's do HTTP. Let's get, all right. And so what I'm gonna do now is messages, maybe, yeah, I'll do messages. So we'll handle that here, okay. And so what I need to do now is to define these messages. So I need to define what the list messages handler looks like. We're gonna do, oh, well actually what we're gonna do instead, actually, yeah, and I'll do list messages. Yeah, we're gonna have a, do you ever define a route to get to the database directly, skipping the cache? Oh, that's a good question. Yeah, so with the post request, so when we create a message, we're going to be creating it. Oh, so you mean like getting it directly from the database? I mean, we could create a backdoor, endpoint to go directly to the database, if maybe for testing purposes. In like an actual application, there might be a reason for doing that. For example, we have never actually created an endpoint that goes directly to the database. We always have a cache in front of it, or if we're using a cache, we won't create a specific endpoint to go to the database. But I could definitely see in a scenario where maybe like for some reason the cache is faulty or something like that, you might want to have like a backdoor endpoint that goes directly to the database. We could definitely create an endpoint that goes directly to the cache, or goes directly to the DB if we wanted to. But I think in like a real life setting, it'd be very rare. I could only really see it maybe for like testing purposes. But other than that, not really. I would usually, you have it go through the cache. But that's a good question though. Let's see. So we're gonna do just the lists messages handler. And so when we create this list messages handler, we have to give it a specific signature. So you can see here, all of these handlers have to accept a writer and then a request itself. So let's just copy this. And then, so, because like the reason why I have to do that is because this handle func, where's it at? So this handle func accepts a function that has response writer and response requests. So basically, our function that we pass in here has to match exactly this function, or else it'll throw an error. For example, let's see if I do go, or let's actually define our functions real quick here so we can get rid of these errors. So it's gonna be create message handler, and then also func. Get message handler. Alright, let's see if I've gotten rid of some of these errors. Oh, I misspelled it. Messages handler. Oh, I put HTTPS somewhere. Where did I put HTTPS? 13 and 13. Oh, this one. Let's see. Do I have any compile errors? Nope, it's all good. Cool. Oh, I have. So the reason why I'm getting these like red highlights is because it's like typos. I forgot how do I unset? Let me look it up real quick. I hate having these like red underlying, because basically means like they're just highlighting typos, but in like in coding you have typos all the time. Spell check. Let's do unset spell. What? Oh, where is it? Oh, here it is. Set no spell. Gotcha. There you go. Now we don't have any more of those annoying red highlights. Cool. So we got these blank messages. Let's actually try and make it work. So what I'm going to do here is I'm going to do var. I'm going to basically create some global variables. Normally, in good practice, you don't want to create global variables, but for the testing, like for this, like working on a small project, we can do some global variables just for fun. So I'm going to create my cache. We're going to do cache.new, and just for the purposes, let's do like 10 items. It can hold 10 items. Okay, so let's do, I have to import my, cache. That works. Oh, does not work. What's happening? Let's do, alright, now it's working, I think. Go. Okay, yeah, so now I imported my LRUCache, now I can use it. I'm going to give it a different name though, because I don't like the name LRUCache. I'm just going to name cache, so that way I can use it like cat, like this. Perfect. So now, oh, come on, what happened? Alright, well if it prefers to do that, I'll just do this. Alright, so I'll just keep it as LRUCache. For some reason, whenever I name it cat, oh! The reason why that is because I'm overriding it with this level of cache. Oh, that's fine. We'll just call it cache. And then we don't have a database yet, so we're just gonna create empty variable database. That's of type SQL database. We'll be adding the database in later. In a second. We'll probably use like Docker or something like that, and import like a Docker, like a MySQL Docker image. Maybe Postgres. I do MySQL a lot at work, but I kind of like Postgres better, so we'll do Postgres. What's up? What's happening? var expecting name. How did I do that? Oh, this is why I put var twice. There we go. Oh, and just make things a little clearer. Separate out packages. So this way we have it as like standard library packages go up here, GitHub packages go here, then my own packages will go here. All right. So for lists messages handler, what we want to do is, since we're listing out our messages, we'll probably want to first hit the cache, see if it exists. If it doesn't, then we'll go and get from the database. So let's first do, so since our cache is based off of keys, what we'll do, the key we'll use will be actually, maybe what we'll use for the key is actually this endpoint. So we'll store responses based on this endpoint as our key. So what we're gonna do is we're gonna do cache get, and then we'll pass in, let's see, probably I think GorillaMux can give you the endpoint that you want. I'm looking for basically, I think GorillaMux gives you the ability to pull out. Oh, I think it might be from the request actually. It's from the request. Request as a method. Oh, it has a URL. Okay. So if I pull the URL from the requests, I should be able to get the endpoints. Let's see, URL. URL has, I think the path. This should be it. This should be that path. Let's just, so what we're gonna do is we're gonna do our URL path. So the path will be our key. So this would be the val. And so if the value doesn't exist, like if there is no value at that key, the value is gonna be nil. So if we do val equals nil, then actually no, maybe we should do this instead. We'll do like, if the value is not nil, then we'll like return it. The way you do that is like we have to response writer. So the way this works is that whenever you want to return JSON, you're not actually gonna, this method does not have a return statement. So basically what we're gonna do is we'll be writing the response to this response writer. What method does this have? And the response writer just has a write. And so it has this write method, and you basically, this is where you pass in like a JSON body. So what we're gonna do, so if the value is not nil, we're going to, in that case it's gonna be, it'll be like a string. In that case it'll be a string. So then we're gonna make it, we'll just do write, and then value string, and then we'll cast it into a string of, like, array of bytes. I was actually, James, if you're still here, this is relevant to you, because in C, if I remember correctly, strings are actually just arrays of bytes, and it's actually kind of similar in Go. Go, you do have a string type, but string types are immutable, so you can't actually change a string. You can't change, like for example in Ruby, you can do like, if you have like a string, so this would be a string equals blah blah blah, and then you could do something like string character at the index, let's do like index 1, equals some other character. You can't do that in Go. In Go, strings are immutable. So it's kind of similar where if you would want to, if I wanted to actually change this string, I would need to first basically cast it into an array of bytes. And then if I want to change it, then I can change it if it's an array of bytes. But string itself is immutable. So that's why, like, for example, in this write method, it doesn't accept a string, it accepts an array of bytes instead. Because that's kind of like similar to C, how C is strings are just an array of bytes. So that's what we're gonna do here. First, we're gonna cast the value to a string, and then we're gonna cast it again to an array of bytes. And then we'll also do write header. We'll do a HTTP status. Okay, there we go. We're writing it as, we're saying that we're gonna return the response from the cache. No, it's a good question. Yeah, so no, in Go we don't have to do like the terminate with nil. You know how you do how in C strings always terminate with nil. No, it's in Go you can strings can, or you mean like oh yeah. So actually that's a good question. I don't think so. We can test it out actually. We can like create a string, cast it to nil. Actually, let me do that real quick. I'm just gonna. We're gonna do print line. Let's do hello. I'm actually curious now. I'm pretty sure it doesn't terminate with a nil, with a nil character, but I'm actually curious now. So we're just gonna print it out to the console. And so if I go, where am I? Okay, so I do go run main. So let's see, 5 characters. 1, 2, 3, 4, 5. Yeah. So no, it doesn't have the terminal character. Maybe under the hood it might, but not at least in the main Go language when you use it. It doesn't have a terminal character nil. Oh yeah, that's a good thing to know about. That's a good question. So let's comment that out. All right, so so if it's not nil, we'll do that. Now, if it is nil, so if we get to this point, actually we have to return after this, or else it's gonna keep going. All right. So if we get to this point in the function, that means make sure to return at the end. If we get to this point in the function, that means it was nil. So we do need to do. We actually need to query the database. So we can do query, and it's gonna be just like select. I guess what message? What's the message gonna have? I guess it's gonna have like text, right? The message will be like. I'm trying to think. Like I haven't really thought about what the database schema is gonna look like. I guess we'll just have an ID column as usual, and just text maybe. So ID and text from messages. And that's it. And this returns rows, I believe. This will return. What does it return? Rows. Yeah. Okay. So we get the rows back, and then what we need to do next is for rows.next. So it's iterating through all the rows that were returned. So let's actually define some. So we're gonna create some types. So a message is gonna have an ID, which is gonna be an int, and then some texts, which will be a string. So what we're gonna do is we're gonna iterate through the rows, and then we're going to basically for every row that we get back from the database, we'll turn it into a message. So we're gonna do, it's gonna be error rows.scan. Oh, actually first we need to allocate a message first. We're gonna create an empty message. Create message. Allocate empty message, and then we're gonna have basically pass in the pointer to our message. ID, because we have to do this in a certain order, because since we asked the database to first return ID and then return text, what we're doing is we're allocating an empty structure, so empty message structure, and then we're populating the values in the fields. So we're going to populate the ID field, and then we're going to do populating the message text field. And so if there's no and so then so there's a possibility this returns an error. So if error, then we'll just what we'll do is like actually we'll create a log too. Actually no, if error, then we'll do OS exit 1, and we'll log the error to the console. Print line. So we'll just print the error to the console, and then we'll exit out. We'll exit out with exit of 1, a value of 1. That works. Okay, so that works. Yeah, so basically, what this is basically saying is that actually the way we can do this even faster is if we just create a log at the very beginning. So do log, actually, LL. LL is kind of a common like usage pattern we do at work. Log.new. We're gonna creating a log, and then we're gonna do, so basically log fatal. So we're gonna do log fatal F. Error. What this is gonna do is it's gonna, or log fatal basically means that we're gonna output a log message and then we're gonna exit out the program because it's a fatal error. So error, and then we're gonna do that. We're going to pass in the error string. And then so that will basically exit out of the program with an OS exit of 1. So it's equivalent to printf followed by a call, call to OS exit 1. Basically what we did before. So we'll do a fatal error. But if there is no error, then what we're basically going to do is we're going to, let's actually create a messages array. Since this is the listening endpoint, we'll need an array of messages. Actually, I'm curious, does rows have length on it? Oh, query. Rows have a length value. Right. Next result is that column. That's columns. Length. Okay. Oh no, column type. I don't know. I think it doesn't. No, I don't think it has. I don't think the rows. The reason why I want to know the length is that way I can pre-allocate the array size, so that way I don't have to keep. Basically with Go, if you create an empty array, then you keep adding values to it. Under the hood, what happens is it has to basically keep making the underlying array bigger and bigger and bigger, which can be a little slow. I think for our purposes, not that big a deal. So I'm just gonna create an empty message array, and then what we're gonna do is we're gonna append the message to that. Which is message. All right. So basically, we're gonna create a database. If the database comes back with rows, we're gonna scan the rows, create a message, and for each message, we're going to append it to our array of messages. That makes sense. And then what we're gonna do is we're also going to create type list response. So we're going to create a new structure called list response, and it's going to contain messages field, which is going to be an array of messages. And then we're also going to add a JSON tag to it. Go add tags. What this means is when we turn this structure into a JSON string, it's going to turn this field into a JSON field with messages. If we didn't add this, what would happen is it would create a JSON field with uppercase message. So it would look like this. But we want to have it lowercase because JSON typically is lowercase, so we want to keep it as messages here. Basically telling the structure to when it gets turned into JSON, make this field lowercase messages. So what we're going to do now, so assuming this succeeds, what we're going to do is we're going to do essentially the same thing we did here, but slightly different. So right now we have a string of messages, or array messages. We want to turn that into a JSON string because we want to return JSON from our handler endpoint. So what we're going to do is we're going to turn that into a JSON string. So if we could do JSON, I think it's Marshall. Let's do Marshall. Come on, let's save that. I should import it, and I should be able to read it. All right, so JSON Marshall. What do you got for me? So it takes. Okay, yeah. So this is what we want. So it's going to take a structure, and it's going to return back a JSON string. So we'll just call this JSON. It's going to return back an error if it is an error. So we're going to create a list response structure. Messages is going to equal messages. So basically what's going to happen is it's going to turn this structure into a JSON string. And then, so if there is an error, basically do the same thing we did before. We're gonna do the same thing we did before here. We're just gonna log it. About that. We're gonna log it out. And if there is no error, then we're going to just do the same thing we did up here. And just end it with that. In this case, it's gonna be JSON. Oh, actually, because it already returns, so this Marshall returns a array of bytes and not a string, so actually we don't even need to cast this to an array of bytes. We can literally just do JSON. Cool. Another thing, actually, one thing I realized we need to do is we need to do, I think it's header? Yeah, header add. And we need to do, we need to add like the JSON type. Oh, what's that? I always forget this. Should be, oh, it's a content type, that's what we need. Content. Let's do, should be, or, I'm just gonna cheat a little bit. Golang, should we add content type? I think it's just like header add. I'm sure they have a, okay, so header set. Okay, that's what it is. Okay, let's do that. So header set, and then we just need to do copy this. Basically what it's saying is that the response is going to be JSON. I don't think we need this necessarily because it's like, you know, we're creating our own API endpoint that people don't really depend on, but just for good practice, we'll put the content type here. So we'll copy that and add it here as well. Actually, what we can do is we can go to the very beginning. We can just add that here, so that way, whether we return from the cache or from the database, we're going to we'll all have content type of JSON, so we don't have to worry about it. All right, cool. Oh, actually, I noticed one thing that we probably actually shouldn't do OS exit 1, because technically, if there's an error, we should return a 500. We shouldn't return necessarily a log. Oh, we should log it, but actually maybe we'll do this. We'll do printf. So we're just gonna print out the error, and what we'll do instead is we'll just return this as a status internal server error. All right, that's what we'll do. That way, we'll actually get it'll act like a legit API endpoint and not just like crap out on us. All right. Messages. Oh, I get an error here. Oh, what is that? Let me know if any of this is not making sense or if you have any questions about this. I know I'm going kind of quickly through it just because I understand Go pretty well. So for me, it makes sense. But if you have any questions or want to learn more, definitely ask. All right, so no, there's no unless in Go. I wish there was. I think I'm pretty sure. Oh yeah, thanks to you too. I wish there was. That'd be nice. Although I always found like unless is nice to read, but still like whenever I read unless, I still have to mentally think, okay, unless means like not if or something like that. Like it's still like I guess like I never solidified in my head that like, okay, unless means like I still have to convert it back to like not if or if not. But yeah, no, it definitely is. It is very nice to read. All right, so actually I just realized that I'm using L here, not log. Same here. All right. All right, so now what I have to do. Oh, what's going here? Log new. Oh. Because logger out variable sets the destination to go to standard out, or after the log header prefix and flag int. I don't know what that means. I guess we'll just do. Okay, instead of creating a logger, we'll just do log. I think by default it's gonna log to standard out. I don't have to like specify it. All right, so now what we're gonna do is now we're actually gonna create our database. So what we need to do is we're gonna need to have we're gonna need to pass in as environment variables the database like username, password, host, and the database we want to use. Let's look at the documentation for that. Golang SQL Postgres. Basically what we'll need is we're gonna need to do like something like this. So we'll need database user, database password, database host, and then database name, the actual name of the database. And so we can do, this is a pretty common practice we do at work. So basically we're gonna set these as environment variables, and it's just gonna be like database user, so then password, so we do database host, and then we'll just do host here, and then database name. So we'll pass those in, and then one thing I forgot though is how do we actually log into the database. I think there's here you go. Scroll down real quick. Yeah, so basically we'll need these things. Oh, maybe port 2. I think the port's gonna be standard, but we'll do they'll do port 2. Port. All right. So let's log in. We're just gonna import the package, and then all right. So all right. So we just need to do this. So this is gonna be host port user password, and then name. All right. So that'll be that, and then we'll just be actually logging into it. So we're gonna open a Postgres SQL connection, and then similar to what it says here, we're going to actually ping the database to make sure that the database actually is working. But instead of panicking, we're just going to do similar to what we did here. We're going to, oh, actually, no, we probably should, in this case, we haven't even created our API endpoints yet. So in that case, panicking is probably okay. We can just panic with the error. Panicking basically means that it's going to exit immediately and going to be like, yeah, like, oh, something's wrong. We need to fix this. And then what here's All right, so then new value. Oh, is it return an error too? Oh, it returns an error. Okay, that's what it is. That's why I'm getting an error over here. Okay, error. And then if error, no. The same thing. Cool. All right. What is the limiting here?
But it's not a thing about making it accurate.
Oh, it's just the exporting stuff. Okay.
It's a thing about making it feel right.
GoLint makes me write a comment for all my exported things, but the way we can get around that is just putting 3 dots. These fast little comments. All right. Cool. The pass linter.
If it's an accident,
All right.
that's
That's
an
cool.
error that
What
feels
is?
good, then you leave it in.
Oh yeah. So what I need to do here is actually need to convert this into a number, because a port is not like when we do os get inf, it comes back as a string. Yeah, it always comes back as a string. So we need to actually convert this into a string. So ASCII to int.
It's not a thing about making it accurate.
The thing here is I'm pretty sure this returns an
Making it
error.
feel right.
We can't just. Yeah, so ASCII int returns 2 values, an error as well. So what we need to do instead, so instead of doing this, what we're going to do is we're going to do port equals error, convert that to ASCII int. We're going to do the port. And so then if there's an error, we're just gonna panic.
But it's not a thing about making it accurate.
Da-da. Okay,
It's not about getting all the errors out.
what's wrong here?
It's about getting it to feel right.
Oh, the declaration of error. Oh, this. Alright. So that actually should work. So what we're gonna do now is let me actually do I have Postgres on the computer? I do not. So PSQL. So I can download it. So I'm gonna download Postgres. Probably could. I mean, probably actually wouldn't even need to download it. We could just like do a Docker file. Maybe while it's downloading, I can work on a Docker file. Because Docker just makes it so it's more reproducible. So we have to like constantly depend on things being downloaded to our actual computer.
If it's an accident, there's an error that feels good, then you leave it in.
Docker file.
You know, you want those.
Let's do like Ubuntu or something like that. Where should the base image be? Ubuntu or something like that. Just like a basic Linux thing. Usually Docker files for Go are usually pretty simple. I don't think they need to be that robust. Yeah, okay, so we just need to, don't even need all this. We can literally just do like, I should do like a, oh, is there not a, oh yeah, let's do Postgres. Let's just download it. Install Postgres. Pretty sure we can do it through Brew. Homebrew, yeah. No. I guess maybe it's not pieced together, it's Postgres like this. That should. Alright, I think that's working now. Ubuntu Docker file. So who we tag it as? I think it's like what we can do is like let's do from Ubuntu Gene04. I think what we need to do is we need to basically let's clean up. We have Ubuntu. If I want to make a Docker file, I think we just need to basically add. So we're gonna make a Golang executable. And we need to add the executable to this Docker file. What are they did here? Maybe do the same thing to do. Make it a little simpler ourselves. Just oops. So we're just gonna steal there. Thing, and then yeah, just do that. I don't even. I think this is all from one directory up. Actually, maybe two directories. I have my go mod and directories up. Download. This would be easier if I actually had all of this in my main directory. So what we're gonna do is copy Docker file. Same with the main file. Let's go to directories up. Alright, so I have that here. Let's do this way we have access to the go mod and go sum all in the same directory. Alright. Build it out, expose this to the world. Okay. So that works. That should work. Alright. Let's do that. Did we download it? SQL. Oh. How do we debug? Anyways, let's go with Docker file for now. Next thing we want to do is let's make a Docker Compose file. I'm gonna do the version. Okay, version. Okay, here we go. 3.8 services. This is what we want. So we're gonna be, let's call it API, and we're gonna call it our database. Let's do a Postgres. So build here means we're gonna build it now. Let's do 8080. Same with here, 8080. And then let's do our Postgres Docker image. We need to set up some config variables or environment variables for our Postgres. Maybe just 13.1. Here we go. Alright, so we can actually set some things. So image is Postgres. Actually, we need to just do. I think it's going to use the latest if we do this. Restart always. Alright, let's do that. What we're saying here is that we're going to actually specify the password to be example, actually password, or classic secret. Okay, so let's do Postgres user. Just do admin. Postgres DB is I don't know. What should we call it? That could be admin too. Admin database. And then the host auth method. That's fine. Postgres password, yeah, we can set password, we can set a user, we can set a database name. I think that's it. I think the host is gonna be just like a local host. We need to find a port? Or is there a default port? Oh, they have 8080. I want 80. I don't know. What is Postgres default port? Five, 4, 3, 2. Okay. All right. So we have Postgres. Actually, maybe just do DB. Restart always. We have database name, Postgres DB. Okay. Yeah, it's fine. So we've defined this. What we need to do now? Oh, we actually need to. Okay. Actually, we need to spin up the database first, and then before we can even create it, we do depends on, I think. Is that what it is? Let's do Docker compose depends on. What that means is that if we specify it depends on, then that service will only spin up after the other service spins up. So we want to spin up our database. We want to spin up our database first, and then we're going to do. Where's depends on? I think it is depends on actually. Depends on. Let's start order. Yeah, I think it depends on. And then it's going to be DB. Depends on DB. So basically, when we spin this Docker compose file up, it's going to spin up our database first.
Don't be afraid to
And
borrow.
then what we're going to do
Core
is
progressions,
environment.
little ditties, tiny things.
And so we need to basically specify
Just snatch 'em
these
all up.
environment variables, which we're going to pull into our container image. So db user is going to be admin. Password is going to be secret.
That's one of the reasons why I can churn stuff out.
I think because Docker spins its own network, we're going to do DB because our service here is DB. And then the host, or the port is going to be 5432. And then the database name.
I thought it was not original, not creative. But
Not a big fan of
I
this.
quickly found out that I am not original or creative. I can't make up a new thing.
That's better. The database name is now going to be also admin. That looks right. So both database DB and the user are admin, which we got there. Database password secret. Database host is going to be database here, so DB. It's going to use this for resolving. And then port is going to be 5432 because that's the default Postgres port. All right. The other thing we need to do before we do this is actually run migrations. Because in order for us to actually add things to a table, we can actually create the table ahead of time. So what we're going to do is when we actually make sure the databases are up and running, before we actually create the router, we're going to do execute context or execute, and the query is going to be a migration query. So we're going to create, let's do create table. I think Postgres says that if not exists, right? If not exists, Postgres. Yeah, it does. All right, so create table. If not exists. If not exists, messages, and then ID, integer, data type, and then it's primary key. Is that how you specify it as a Postgres? Yeah, primary key, okay. Primary key. And then we do messages. Let me a text, because technically the message could be anything, or message. Text. Not null. Alright, so I think that should be fine. And then if this causes an error, then we'll panic out. Alright. Oh, I don't need that because there's already here. Alright. So we're going to create this migration. So if the table doesn't exist, we're going to create messages table, which has ID and message. Oh, I actually have message. There we go. Message. Text not null. Right. Alright, let's actually but even before we do this, let's just we need to Docker compose up. Let's see what happens if we do this. I mean, there shouldn't be any errors. I mean, at least the compiler doesn't have any errors. Alright, so no errors to compiler, much means some linting errors. Alright, linting passed. Yeah, let's just do oh, where's the Docker compiler? Where is this Docker compose file? Okay. Oh, that's right. So what we're gonna do is move the Docker compose file up as well. Alright, let's do Docker compose. Is that just a general port or it has to be 5432 is Postgres's default port. So I think when we spin up a Docker container and we have it as so if you go to Docker compose, oh, what are we doing? So with our database service, because we haven't specified a Postgres port, the default port is going to be 5432 because it's Postgres' default. So that's why I put it here. It could be that maybe this spins up something else, or that we could specify a port if we wanted to. I'm just going to try it like that and see if it works. I'm not 100% sure it's going to work, but I think it might. Let's just see. Here's the moment of truth. Docker compose up build. Oh, what the? Oh, I might even have Docker compose installed. Well, that was anticlimactic. All right, Docker compose does exist, and it's down. It's being installed. Just waiting for this to install. I think I need to double check is that this. Oh, so be right back screen does not have my audio output, so I need to change that. Can I do it on the fly? Let's try. While this is downloading, I'm going to try something real quick. I'm just going to add audio output capture. Source. Alright, so now you should be able to hear my desktop audio on the be right back screen. Just in case I need to go back, be right back. Almost there. So actually, while this is downloading, I'm actually gonna be right back and go to the restroom real quick. So be right back real quick. Alright, it's back. It looks like it's finished down the slow song. That. Alright, so let's see if Docker Compose works. Did that work? Alright, cool. It is, in fact, downloaded. Let's go have another drink. Alright, so let's try that. Docker Compose. Moment of truth. Is it gonna work? Up, build. Okay. Alright, let's do something about that. What's happening now? What kind of errors are this? Do I not have Python 3? I do. Let's go. Maybe try and change the version type to 3. Oh, do I have Docker? Oh, I don't have Docker, that's why. Oh boy. That's a little embarrassing. Let's get Docker first. Alright, what can we do in the meantime? Let's add another, do we have Postgres? It should be there. Alright, Docker's working. Let's see. Docker. Man, what is up? What do we get? Docker. Let's go Docker version. Oh, Docker daemon. Oh, you know what the issue is? I don't have Docker for Mac. Let's install that. That will be crucial. This is an entirely new. I have Docker on like my work computer, but this is like my computer I use exclusively for streaming. So I realize I don't have a lot of dependencies I need. But that should be working now, hopefully. Got 32 seconds left. Let's do services start Postgres. Just in case this isn't Docker Compose not being friendly. Alright, cool. So actually, what the heck? Alright, another error to look at. 5 seconds left. Let's see how this works. Download Docker. While that's going on, do a camera Postgres locally. Starts. Oh, it's because this is for Linux. What verification? Oh, it means like when I'm downloading something, it's gonna ask for verification. Oh, this thing, yeah. Skip. I didn't realize you can do that. I'm so used to like waiting for it to finish. Oh, is that what it is? Wait, what the? Did I not? Oh, I think I didn't install the right package from Brew. It's PostgreSQL. I think I put Postgres. I mean, they should know, right? There should be like aliases. If it's Brew install Postgres, they should do PostgreSQL. Yeah, see, there we have it. Oh no, not the one. All right, now just right now it's copying document applications, but because I'm streaming, I think it's gonna take a little. It's gonna take a hot second just because my computer's a little bogged down. All right. So we got Docker running. How the heck? Why is that not? Why is it not working? Damn. That's crap. Services start. All right. Seeing connections. Dash down this way. Yeah, that'll work. For some reason, Brew isn't working. Come on. You have to do the whole security allow thing. Oh no, there it goes. I'm just setting up Postgres right now on my computer using that install wizard. Let's see if it works. Never had this issue before. I feel like my other computers was able to download Postgres through Brew really quickly, or just pretty simply. But for some reason, I'm getting this error. Blah blah blah. Let's see, did I already? I think I already looked at the error. Let's look again. Are there other suggestions for this error? All right, right now it's like a race between, you can see, it's a race between Docker and Postgres. They're both downloading. We'll see which one downloads first. That'll be the version we test first. Either we test it locally or we test it through Docker. I think Docker might this one. It says 10 seconds though. It's still being a little slow. Yeah, so I think part of the reason why it's so slow to download is because my streaming computer is a 2015 Mac, and so I'm sure the specs for this 2015 Mac are not as nice as like the 2019 ones. But it works well. I'm not 100% sure. When you say HDD, you mean like oh, like a hard? I think this is solid state SSD. I think it's SSD. I'm pretty sure because I remember being with my wife when she bought this computer, and I'm pretty sure the salesperson was like, "Oh, you can get a hard drive or you can get SSD," and like SSD is like state of the art, much faster. And I'm pretty sure she went for the SSD. I'm on a MacBook. All right, so I think Docker just finished. All right, verifying Docker again. Postgres still going. Move that over. All right, I'm trying to get Docker to get spun up. Almost there. I feel like we're almost there. Alright, I see the icon spinning up. Alright, once that's up, we should be able to use Docker. And then I can start debugging the Docker Compose issues. I think this is the Postgres. Oh, it's Evernote. I need Evernote. Let's look at my HTOP. Let's see which stuff is running right now. So we can slobs, OBS obviously taking a lot of memory. Excuse me. What else? Docker, Streamlabs. Basically, Streamlabs, Firefox, and Docker are all taking up the most of my computer. My computer's bandwidth. Alright. Almost there. Come on. Just do a Docker version. To me, so we have the Docker client, but what we need is this part. So error response from daemon. This is the daemon that's being spun up. We just gotta wait for that daemon. It doesn't really matter so much if we have the Docker client. We need the daemon. We need the Docker server on our computer. Do you know for sure if you can look up like so about this Mac? I want to see like how much RAM I have. Memory, oh, 16 gigabytes. I mean, that's not bad. Probably would want more than that though. Like 32 gigs would be nice, but I'm pretty sure Macs you can't update. It's probably running like a desktop or something like that. I think even iMacs you can't update either. Oh yeah. Alright, what's this? Oh, try container. I don't need this. Okay, so I think, yeah, let me sign in. ID. I don't think it matters so much. Yeah, as long as Docker's running. Alright, cool. So the daemon's running. Alright, so now that we have all that running, let's actually try Docker Compose. Wait, I think we're in the wrong file. Oh, wait, oh no. Alright, let's go. Let's see it work. So it's pulling down the image from Docker. Good signs, good signs. It's doing DB first, which is what we want. I think also the reason why, I think 2005, 2015, I think it only has like 2 cores, right? Maybe you can, I mean, Marcus probably has, you probably have more knowledge than I, but I think like 2015 probably has only 2 cores, whereas like I think the newer models of MacBook, did I speed your SSD free one? Oh yeah, I probably want to do that. If I'm sure, like, you know, it's 5 years old. I mean, it's not super old, but definitely This is what you're talking about? With the source of that magic. Oh wait, go back. I think it's this one, probably this one. Alright, let's give this disk speed test real quick, just to see what it's like. Let's see how this Docker Compose is going. Yeah, still waiting. Oh, it's gonna freeze up. Maybe I won't run it right now then. I'll wait for after this Docker Compose to run, see if it works. I'll download it, but I won't actually run it. I'll run it later. The good thing I actually emptied up. So before yesterday, I was going through the computer and emptying a lot of space because this used to be my wife's computer, and so she's a designer, so she has a lot of like do it later, try 1 GB to 8 option. I think it's a MacBook Pro. I'm pretty sure it's a MacBook Pro. Maybe the about will have more. MacBook Pro, yeah. Quad core. Okay, so that's 4 cores. Okay, so it's 4 cores. I don't know. I think it just made it older. Probably that's why it's slower. Storage. Yeah, but yesterday I went through so like yeah, I don't know. I guess like my my newer MacBook just feels faster. I have the 2017, I think, for my work computer. It just feels faster than this one. But it's also like I'm streaming at the same time too, so a lot of the RAM is getting used up. So I'm sure that's probably why it feels slower. All right, we're almost there though. I really want to see if this works. The thing, if using Docker would be very nice. So are you able to like actually like oh, I got panic. Oh, for the import, okay. Yeah, video, yeah, editing videos, that's definitely true. But are you able to actually switch out like SSD stuff? Cause you said like yeah, actually what GPUs do MacBooks have? You said you switch out the SSD. So like, are MacBooks, are you actually able to actually switch out components of it? I thought it was like a closed system. I have to, oh, okay, that's what I need to do. Oh, did your sisters one have like a C hole? That's how you're able to, like a C port, that's how you're able to do it? Alright, I need to panic because it doesn't have Postgres registered. I need to import the Postgres package. Oh, drivers, here you go.
No matter how beastly and huge dinosaurs were, the fact remains that they went extinct.
Alright, let's do
A reminder that sooner or later, the universe will be.
Alright, let's go with this one. Basically what I need to do is, the reason why I need to import this before it works is because what happens when I import this Postgres package is it registers itself with the SQL package. So this SQL package here, it needs to know about certain drivers before it can actually connect to them. So by downloading this Postgres package, it's going, when I import it, it's going to register with the SQL package. And that way I can connect to a Postgres thing. So let's see how it works. For a long time, the story was a standard, but apparently it has lost its relevance and is not developed by its author. Let's actually look at these real quick, see if they're actually true. I mean, this still looks like it's relatively 0.5. Oh, this is a newer one. This is still 6.2. Oh, I guess this is older though. It definitely hasn't been maintained in a while. This one seems a little more new. 3 months or 17 days ago. Yeah, definitely seems a little more relevant. Okay, let's try this one. All right, we'll do that, and then we'll try Docker and Postgres again. Yeah, I guess you're right. 16 gig RAM is good enough. I just feel like with cause I mean, if you look, let's look at here again. I feel like I shop Docker, slobs, like CPU usage. That seems way too high. 220% doesn't seem right. The memory, quite a bit too. This is Docker, I guess. I mean, nothing's really doing swap. I don't have too much swap happening. But yeah, I have 8 cores. Yeah, I don't know. I guess you're right. This computer is definitely good enough. It's like I'm streaming right now, so that's why it's slower. It just sucks to have to wait to download stuff. All right, what's happening here? Oh, come on. What happened? All right, let's go to this. So I'm using this one. All right. Oh, what? I want this. Oh, I think I might have to actually use this one. Alright, so let's get rid of this. Oh, I already got it. Okay. Already got that. Okay, so what we're going to do is we're going to import Postgres package. So register. Something weird's happening. Just gonna put it out of these, and then what the heck is going on? All right, all right, so that's registering. Oh wait, no, I didn't want this one. I want something else. Let's do this one. I want this one. we're gonna do, go here. There we go. All right, so this should register the Postgres package. So that way, what's happening? Oh, I actually do this. All right, that's fine. Let me do go build, make sure that compiles fine. All right, good. So the reason why I import the Postgres package is because when I do down here, open Postgres, in order for me to do this Postgres thing, I need to have a driver first. So by importing this driver, it'll register itself with the package, and then I can do open Postgres. Fingers crossed it should work. Just get rid of these things. All right, get rid of that. All right, do this. Now let's do Docker and Postgres. Fingers crossed. All right, downloading the mod. Probably a better way would be to actually create the executable and then have that download, but it's whatever. It's a little slower. Or do you like build the executable before Docker runs so we just push the executable to it, but it's fine. Oh yeah, what's happening? What happens? What happens? Come on. Something's happening. Let's go, man. Do I have a message here? Let's do real quick. Log. Oh, yeah. So we're not missing logs happening. Just to be 100% sure. Alright, select. Oh, you know what's happening? It is connecting. Okay. I know what's happening. See, it's exiting with exit code 0, meaning it succeeded. But what's happening is I'm not stopping. So, okay, no, I know what's happening. All right, so what's happening is when it gets to here, handle, it doesn't block. It doesn't block the executable, meaning like it goes to here, it does this, and then it stops. So like it goes, this is the end of the main function, right? So it just finishes. So it finishes successfully, but what we want to do is actually start up the server and block and actually wait for requests. So I must have missed that part with the Gorilla Mux. Where are we? All right, so what we need to do? Yeah, so this is what we need to do. So we need to actually do router and then do this. This is what we need right here. All right, so we'll just copy this. So after we've done that, then we do here. So our thing is gonna be localhost 80, but it's gonna be 8080 actually. I put it as 80. Localhost 8080. There we go. Okay, so handler is gonna be R, like we did it there. Our address is gonna be localhost at 8080 port, and we're gonna enforce some timeouts. And so this is what we wanted. So this listen and serve, it basically stops the executable and basically allows, you can see here, listens. So it basically stops and it listens on TCP port 8080, which we have. So this is what we wanted. Alright, so actually, but it's good though. That's, this means that like the Docker file is working, and so all we need to do now is do it again, and now hopefully it's gonna block, and then we can actually do curl requests against our API endpoint, and we can do it that way. So this way, this will test if our API endpoint is working. Alright, so the database is up. Doesn't mean the API is up. Oh, what we need to do is we actually need to log out. So I mean, I think it is working, but I just want to be 100% sure. I want to create a log statement right before here. Just gonna do log print line listening localhost 1480. Alright, so if it gets to this point, then we know it's working. So get out of here, compose, upbuild. Alright, so wait, we want to see that log message. Alright, so listening, oh, I misspelled it, but listening at port 8. Okay, perfect. So now let's try that. Let's do curl localhost 8080 and do messages. I think that's okay. Let me do this. Alright, I think what we want to do is so I specified I just look real quick where it's at. Does this accept anything? Address. Address for this on in the form or if empty is used. You know what I'm gonna do? I'm going to do port 80. So this should default to port 80. Just to make things a little more simpler. And then what we'll do here is the closed. Oh, it's because tab it. Tab it. Close. Fine. It's gonna be 80 here. We do port 80. All right. Do this, and then. It's still gonna say listening on port 8080, but it should be listening on port 80. Oh, what happened? Missing a port and address. Okay, so I do need a port. Alright, that's fine. Let's do port 80. Yeah, talk later. Thanks for joining. All right, so it is listening. Let's try again real quick. So I think something's up because we would see, I think we would see messages here that we're getting requests from our API endpoint. So something is up. Let me look real quick in the documentation. What do you mean? The music or the documentation? The music we have is just like the code. Let's go, man. Doing Golang. Right now I'm trying to make an API right now using some Go. Do you know much about Go? 800. Alright, let's try something. So, Node.js, yeah. Yeah, I want to get more Node.js later. I use a lot of Go at work, so that's why I'm doing Go right now. I definitely want to do more Node.js. I've touched Java a little bit, not too much. But Node.js, like, I mean, I guess I'm not the hugest fan of Node.js, but like, I do recognize that, like, you know, a lot of companies use Node.js and like it's pretty popular. I want to use like Next.js. I want to update my website. I think a lot of people use Next.js. Next.js is kind of like React and Node.js combined together, right? Do you know Next.js? Now let's see if it works. Man, that's weird. Off. Let's go. Fucking. Basically what's up is I kind of wrote out a LRUCache, and so right now I want to actually build an API endpoint to test that cache. And so I have a database that I'm trying to connect to, which is working through Docker, and then I've set up some API endpoints. And right now I'm trying to test this API endpoint right now, so the messages endpoint, but it doesn't seem to be working a ton. Actually, let's, I don't know, for some reason, let's see if this is in the college. Oh, nice. How are you enjoying college? Actually, I got a job. I got a job before I got a degree, but I actually went back to college after I got a job to get my CS degree. So I know, like, so how are you enjoying college so far? Yeah, I remember I took like, the college course I took, it taught like 3 different languages within like the time that you were there. So I mean, it's kind of cool, but like you barely learn any language at the time. So like I learned CS, I learned C++, I learned Python, and I learned Java. But I don't know, I remember any of them. I mean, I can understand the language, I can read it, but to code in it, maybe Python. Python was the easiest. But yeah, it was like kind of a clusterfuck of it, because they taught you so much way too fast. It'd be way better if like they stuck with one language and just kind of taught you that the entire time. But yeah, it was like, oh, here's a course, C++. Okay, next course, let's do Python. Something's up, something's wrong here. Oh, do you do a lot of competitive coding? I've looked a little bit into that. It looks pretty cool, but I just feel like I don't really have much time to look into do it. But it looks pretty fun. I definitely like the, you know, doing like fast algorithms and like trying to develop algorithms really fast. Let's do that actually. But why do you prefer C++ for competitive programming or competitive coding? Wouldn't like Python be easier just because it's so, I guess it's like faster programming, just because you can, I don't know, you can do more faster? Or is it like with competitive coding, is it more like the faster solution is better as opposed to like one you can develop faster? Like C++ you can compile down and it can execute faster as opposed to like Python, which is a dynamic language which you read line by line. Like, is it more like the faster solution as in like runtime faster is better? Or like the faster you can develop the solution, the better? Oh, okay, so you're saying like the C++ standard library is really robust? Gotcha. Yeah, I only did like a little bit of C++. I actually did more Java and Python. All right, so 404 works. Empty reply from server. Maybe it is working in. Actually, let me log something. Okay, so we got something. What's going on here? So we got something. What caused it? Is it this stuff? Alright, that wasn't it. What was this? Alright, so that works. Alright, so we're getting somewhere. 127 messages, so what was the panic? So it was at line 99. Nil reference? What is that? Relation messages does not exist at character point 2. Oh, you know what it is? I haven't created the table. No, I did create the table. Oh shoot, that didn't get saved. Oh damn, okay. I didn't actually create the table. And for some reason that didn't get it saved. So create table. Yes. I don't know why that didn't get saved. I definitely created that. But what's your kind of hope for after college? Do you have like specific places you're hoping to work at, or you're just kind of just hoping to get a job after college? Okay, that's right. Oops. Do not have a... Alright, so that works. ID, share key, message, text, no. Statement, we're done. What's wrong with that? Oh, I think maybe this last comma is it needed? Let me look at yeah, okay. I think that's probably better. Let's try that again. Alright, so now I was able to do this, but just in case. Alright, so let's try it again. For some reason I'm not getting messages now. Why is that? I don't know, whatever. Oh, Davis was shut down. Oh, wait. Very confused. Man, what is happening? Let me just do like a log real quick, I guess. Let's try it again. This is not working. Add request. Yeah, this looks. Like cat, you can't have cat. Right there. Alright. You know what I'm gonna do? I'm just going to comment out, to make things easier, I'm just gonna comment out these functions. So you don't have to worry with those. And then we're also gonna comment out these as well. And then this is just gonna be the blank. And then do that. Yeah, look at that. And then server, that. Is the default port 8000? That was the. Try 80 though. Give it 80. 80, and then make sure that the Docker post file. Oh, here's the issue. I think. I don't have 80. Okay, 80. Works. That should work. So then let's do this again. Alright, so we're just gonna do that, and we're gonna try a request. So I've got rid of these. This should now go directly to the list messages handler. Do a curl. Yeah, okay, I'm not totally sure what's happening. Alright, should we try 80 again? Let's try it. So 8080 does work. Because it's not getting the fail to connect. Actually refuse. But what the heck is going on? Oh, wait. Is this? Alright, I'm not totally sure what's going on, but it's been about 2.5 hours. I'm gonna call it good. I'll keep working on my own, but have a good night, everybody. Thanks for joining in.